Okay, we talked about structures and just a quick review of arrays, and then we're going to talk about collections. So arrays, we can declare an array like this, and this will be an array of integers, and it will hold 16 integers. Remember, it's one more than the number here. We start with 0. We can assign, here's an array of names. We can assign values to it like that. We can assign numbers to the salary one up here, and so on. We haven't really talked too much about, but there's another object as opposed to an integer or a string or whatever, which is color. And so we can define an array with color entries, and we can refer to the 0th entry, and color has various possible colors associated with it, and this is how you would assign to the different elements in the array. So up here, going back here, we had names and salaries as two separate arrays. And then if you wanted to access that, so suppose this was the 0th element stood for this person, and his salary was the 0th element of the salary array. And then the first would be this person, and this would be the salary, would be the first in the salary array. An alternative is to, a better technique for storing names and salaries is to create a structure. So we just finished talking about structure in a different video. So we create a structure with the structure and structure keywords, and we say, okay, let's call it employee, and it's going to have two variables in it, name, which is a string, and salary as a decimal. Now we can create an array. This is creating an array, right? And the data type is employee. So now to fill in an element of this array, we have to actually fill in two parts for each element. So like for this element 2, which is actually the third element, we'd have to fill in, we'd do this. This would refer to the second element and the name part of the structure, and this would refer to the salary part of the structure. So this would be the name field of the structure, and this would be the salary field of the structure. And this way, you know, we don't get confused about the index. Like before, if we might have made a mistake, right? You know, we have to make sure that we're using the same index for each person in the name and the salary. But in this case, we don't have to do that, right? It's kind of done for us. So they say the advantage of using an array structure instead of multiple arrays is that related information will always be located under the same index. The code is more compact, and you need not maintain multiple arrays. So we make a structure and then make an array of elements that are elements of that structure. Okay, we also did initializing arrays before, and you can have the name of the array and the type, and then you can actually fill in the values. So instead of just declaring it as a particular type, you can use the equal sign and fill it in, or that's called initializing it. So here we could create the names as string array, and then we could actually fill in the first two elements. And that's just the same as doing this first. This would mean there's going to be two elements. here it's implied that there are two elements. Okay? And do this. So I sort of made a mistake. You can't add new elements to the array without resizing it. If you need to resize an array in your code dynamically, you have to use the redim statement. But we're not going to do that here. Okay, we can talk about the array limits, which basically means the lowest element in the array and the top number of elements in the array. The lowest number of elements in the array and the top number of elements in the array. And we can get those by doing, suppose we have an array like this, has 20 elements. We can refer to that array and then use this method called the getLowerBound, and we'll get 0 means it's the first element in the array, and we can use the getUpperBound, and that means 19. That's the last index of the array. Okay, and the 0 here refers to the fact that so far we haven't talked about multi-dimensional arrays, so we're just talking about a single dimensional array, one-dimensional array, and so we're talking about the first dimension of the array. This is the only one that we're concerned with so far, and again we start with 0, so instead of saying the first dimension we say the 0th dimension. There may be other dimensions. We might have more than a single dimensional array. For example, you probably know what a matrix is. So a matrix is like a two-dimensional array. Has 2 dimensions, right? So we might be interested in the second dimension, getting the lower bound for the second dimension, or getting the upper bound for the second dimension, and then we wouldn't use 0 here. And some place where we might actually be interested in using this is if we get the upper bound, we could use that in a for loop. So we go from the first element in the array to and we need to know what the last element in the array is, or the last index of the array is, so we can use this to get it. If you want the number of elements in the array, you have to do something like this, right? Because like that, because this upper bound gives you the, for example, 19, but actually there's 20, so you'd have to add 1. You can also use the length property. So you could you take your array.length, and that will also give you the number of elements in the array. So let's talk a little bit about multi-dimensional arrays. Basically, like a two-dimensional array is like a matrix, basically. So let's see what that's like. So they say a one-dimensional array, like what we've seen so far, is good for storing, a long sequence of one-dimensional data, like a bunch of names or a bunch of temperatures, right? But how would you store a list of cities and their average temperatures in an array? So you want the city and the temperature together. So we could have like a bunch of cities, and that would be a one-dimensional array. We could have a bunch of temperatures, and that would be a one-dimensional array. But how about if we want both together? Now we just saw a way to do it. Actually, we could define a structure and then make an array of that of type that structure. But this is an alternative way, using multi-dimensional arrays. And also for another example of why you might want it, suppose you want people's names and their scores, like their names and their scores on exams, or their years and profits for a company, or you might even want more than 2 dimensions. You might want 3 dimensions, like products and prices would be just 2 dimensions. You have a list of products and their prices. Remember, just a list of products would be a single-dimensional array. Just a list of prices would be a single-dimensional array, but if you want them together, that would be a 2-dimensional array. And if you wanted that along with the units in stock, So you want the products and how many units are in stock and their prices. That would be a three-dimensional array. So again, we could put cities as a one-dimensional array, just a list of names of cities. And then temperatures also could be a one-dimensional array. This would be a list of numbers, of maybe integers, and we could have, the 0th element would be San Francisco and cities, and the 0th element in the temperature would be the temperature of San Francisco, like the average temperature of San Francisco. Now, if we wanted to use a multidimensional array, we could call it temperatures, or we could call it something else, because temperatures actually seems like it's just this. But here we're talking about temperatures, which is not just this column, but also the cities. So maybe we'd call it cities and temperatures. Here they're just calling it temperatures, but maybe it would be clearer if we called it cities and temperatures. All one word, but still cities and temperatures. And we would declare it as like this. Basically, we'd have to use a dim statement, but basically it would be like this: 7 and 1. Remember, that would mean 8 and 2, really. So what that 8 means is that we're going to have 8 rows. Are there 8 rows here? 1, 2, 3, 4, 5, 6, 7, 8 rows, and 2 columns. Okay, so we would declare it with something like this. As I said, we'd need a dim statement. And then if you want to refer to something like this thing here, you would say this is the in the second row and the second column. But remember, we count from 0, so this wouldn't actually be called the second row. It would be called the row with index 1. This is the row with index 0. And this is not the second column. It's actually, this is the 0th column, so this would be the first column. So to get this item, you would say the temperature 1 comma 1 comma 1, right? Right, that would be the temperature 1 comma 1 element, and that would be equal to 86. So here, temperature 2 comma 0 would be what? That would be the third row, and the first, actually, right? This is the first column. So third row, first column. So actually, they don't tell us what's in the third row and the first column, but I guess it's supposed to be. Well, if we go back to here, did they tell us? No. Anyway, so I guess it would be the third city's name, and this would be what? The third row, second column. So that would be the third city's temperature, right? The third city, a 2 would mean 0, 1, 2 row, and 1 column means 0 column, 1 column would be this entry. So that would be the third city's average temperature. The third city's average temperature. Okay, they give us another example. Suppose you're writing a game, and you have a board. It's a board game like checkers or chess or Go. And you want to track the positions of certain pieces on the board. So we need to know the location, all the different squares on the board. So each square on the board is identified by 2 numbers. Its horizontal and vertical coordinates. So like here, suppose this is not a checkerboard because it doesn't have enough, right? I think you're supposed to have, I don't know how many are on a checkerboard, maybe 10 by 10 or something like that. But here this would be how many? 1, 2, 3, 4, 5 by 5. So and we need to identify the location of each space on the board. So each space or each square on the board is identified by two numbers. It's horizontal and vertical coordinates. So this is the column and the row. The obvious structure for tracking the board squares, if we want to know where identify each of the squares, is a two-dimensional array, in which the first index corresponds to the row number, and the second corresponds to the column number. The array could be declared as follows. So this is how you would declare a two-dimensional array, and this would mean what? That there are 10 rows and 10 columns, and this array is they're going to be integer values. So we could have, like, one of the elements might be 2, 3, right? And that would be what? 2, 3 would be or let's say 2, 5. So 2 would mean the third row, and 5 would mean the sixth column. But anyway, we could declare a 10 by 10 board like this. Now if we want to track where a piece is, when a piece is moved from the square in the first row and first column to the square in the third row and fifth column, you could assign the value 0 to the element that corresponds to the initial position. So we might have like a piece, and we'll give it let's just say, so at this position we might say this element equals 0, indicating that the piece is not here, and at this place you would assign that value to the value 1 to indicate that the piece is there. Okay, so we're kind of keeping track of the piece. An alternative to this would be you could assign 0 if there's no piece on there, and the number of the piece. For example, you might have like 5 different kinds of, like if it's chess, you might have different pieces, and you could assign a number for each one, or lots of different schemes I guess you could use. Here he's using 0 and 1. So you could actually search through to find your piece by iterating through all of the pieces, and you could do this something like this: if board 0, 0 equals 1, then piece found, else empty square. Now you could have here's a 3 by 3. I'm sorry, not a 3 by 3. This is a three-dimensional array. So going back to here, we defined a multidimensional array, two-dimensional array called board, and here we're defining a three-dimensional array called matrix. Now one way to think about a three-dimensional array is that it's like a cube. So not just a flat object like this, but a cube, like a die or a cube. I hope you know what a cube is. And then you could talk about the row and the column, and also going back in the cube, like going to another layer in the cube. So you might have, this might be the first layer, this might be the second layer, this might be the third layer, this might be the fourth layer. So you might have a cube that has, how many are here? 1, 2, 3, 4, 5, 6, 7, 8. So you might have the first thing would be 7, and there's 1, 2, 3, 4. So the second entry would be 3, and then there are 4 going back, so this would be 3. And so if you wanted to identify, say, this element here, it would be, actually, they have it here, it's 3, 0, 0, 3, meaning that it's in the, well, maybe they're doing it slightly differently. Let's see. They're giving how far back it goes first, so it's in all of these are 3, that means they're in the fourth layer back, and then all of these are 0, so that means that 0, 0, 0, 0, that means that this 0 indicates that it's the first row here, and then 0, 1, 2, the column is the third one. So I guess they're doing what? This is the layer element, and this is the row element, and this is the column element. So they compare. This is just a single dimensional array with 8 elements in it. This is a 2-dimensional array, and this is a 3-dimensional array. And each position can be identified, like as we just said. This is the 303 position. Now we can also talk about initializing. We talked about initializing an array. It just means giving it values at the right when you we can do it right when we define the array, and we can also initialize a multidimensional array. So here's an example of initializing a 2-dimensional array. Here's 2 dimensions. There's 1 comma, so there's 2 dimensions here. And what you have to do is you indicate the first row, the second row, and the third row. And you're using these parentheses. And so the first row is 10, 20, 30. The second row is 11, 21, 31. And the third row is this. So if you then try to print, here's writing to the console. If you try to write this, you're talking about the first row or the 0th row, but I'll call it the first row. All right, I'll call it the 0th row, and the first column, which is actually the second column. So that would be, the first row would be this row, and this first column would mean this element here, right? So it would print 20. If you want to make it a little clearer the way you write it, in the way that you write it, you could do it this way. Notice that there's a parentheses here and here, as well as these other parentheses. If you want to know how many dimensions an array has, you can use this keyword rank. So if you have an array like this, which has 2 dimensions, I think this will give us a 2. If you type this, you'll get 2, meaning there are 2 dimensions. If you want to know the length of each of the dimensions, you can do employees get length of the first dimension, which will be 2, because this means there's 2. And if you do employees get length of the second dimension, which you do like that, because this is the second dimension, you get 100. The indexing here is kind of annoying, isn't it? This means the second dimension, this means the first dimension. I believe that this is going to give you 2, though. Okay, so finally they say multidimensional arrays are becoming obsolete because arrays and other collections of custom structures and objects are more flexible and convenient. So we saw what we mean by structures already, and now we're going to also look at what are called collections. So I'll continue that with the next video.